This video will help you find angles using right triangle trig. That means we'll be given two sides at least of a triangle, and you'll dive inside the triangle and find the angle. To get those, you still need to know what sine, cosine, and tangent are, and they help you find proportions of sides in a right triangle. A lot of teachers out there use SOHCAHTOA as an organizer of reminding of you when do you use sine, when you use cosine, when you use tangent. I color-coded it. I added big letters for the S, the C, and the T. And when I write it in my class, I like to not think of it as SOHCAHTOA, but I actually will organize it a little bit differently, where I put it kind of stacked, and I think of it as that. Still spells the same word, still organized kind of in the same order, but I visually put the O on top of the H, the A on top of the H, the O on top of the A. So you remind yourself that for sine, it's opposite over hypotenuse. It's adjacent over hypotenuse for cosine, and it's opposite over adjacent for tangent. So I put down here just the coding of the words, just so you make sure you have that. When you see an O, that stands for opposite. In the textbooks, A always stands for adjacent, and I like to think of that as attached. If you don't know the word adjacent, if that's not a common word to you, I think attached is more tangible. It makes more sense. Attached. It's the same meaning, same idea, and it also starts with the letter A. So before we actually dive into problems, I want to make sure we can identify the opposite, the adjacent, and the hypotenuse for any given right triangle. So when you have a right triangle, hypotenuse should be the easiest one to find. It's always on the other side of the 90 degrees. So I'm looking at these three triangles, and I'm going to highlight for you across from the 90. So across from the 90, across from the 90, across from the 90, there is your hypotenuse. I'll label it with an H. Okay. Now the opposite and the adjacent depend on where you're looking from. What angle are you trying to find, or what angle are you trying to use? So let's say I will put the angle in question right there. So you can think about having eyeballs right there. So when you have it in that position, the adjacent is attached to your eyeballs. So your adjacent is the attached side right there, which leaves all the way over on the other piece, all the way over here is your opposite side. So this is your opposite side, and right next to your eyeballs, attached to your eyeballs, is the adjacent side. So let's put in a couple more angles on the next two guys, and we will see. Remember, that means theta, which is just referring to the angle. I'll put it over here as well, which means you have eyeballs in this corner, and you have eyeballs in that corner. Attached to you is where it's coming right out of your eyeballs, and that's the wrong color. I apologize. Attached is green. Attached over here is green, which leaves all the way over on the other side, all the way over on the other side is your opposite, which would be here and here. The reason it's important to go through that is if you pick the wrong sides in your head, if you think this side is opposite when it's really adjacent, you're going to be choosing the wrong trig call. You'd be using, let's say, sine instead of using cosine, and your answer is completely dependent on calling the correct ratio. So let's try an example out here. I'm trying to get that theta, and I'm given, it's a 90-degree triangle, so a right triangle, and I have two things. I have a 20 and a 16. I need to decide, am I using sine, am I using cosine, or am I using tangent? So when I look at that, first thing I do is I'm always going to identify the hypotenuse. It's always across from the 90. So I have the hypotenuse. Now right next to that is my attached. Right next to the angle in question is my attached, which leaves all the way over on the other side my opposite. So now with those labeled, I know I have the opposite and I have the hypotenuse. So if I have the opposite and I have the hypotenuse, I can think about using sine. So when I write it out, I'm going to say sine of the angle. It's always of the angle equals opposite over hypotenuse. So I have sine of theta equals 16 over 20. That 16 over 20, all that is numbers. So you can get that immediately. There's no crazy math involved. Let's just figure out what 16 divided by 20 is. So when I take it, let me turn it on. 16 divided by 20 gets me 0.8. So now I'm down to sine of theta equals 0.8. Now, the big debate here is how do you get theta by himself? How do you get the sine part removed? And this is a little excerpt of, think of inverses. Or you might think of the word opposites. For those, the opposite of plus is minus. The opposite of multiplying is dividing. The opposite of square rooting is raising something to the 2. The opposite of cube rooting is raising something to the 3rd. Those are pairs. If you want to get rid of a plus, you subtract. To get rid of a multiply, you divide. To get rid of a sine, you need to do inverse sine, which is this notation. Okay, so on the paper here, as I write it out, to get rid of sine of theta, I'm going to find the inverse sine of theta. And if you do it to the left, you're going to have to do it to the right as well. On inverses, when you square a square root, that part goes away and just whatever is on the inside is left over. So the inverse sine of theta just gets you theta. And now I need to calculate what's the inverse sine of 0.8. Now, when you do this, just like when you're finding side lengths or when you're finding angles, you need to make sure your mode is in degrees. So right now, when I turned on my calculator, it was in radians. So I'm going to go down and over 2 degrees and turn it on there. Depending on what type of calculator you have, you need to make sure you know how to switch between radians and degrees. On the TI-83, the 83 plus, the 84, the 84 plus, it's all right next to that yellow second button, and it's called the mode key, and then from there you can turn it to degrees. If you use an app on your phone, if you use your computer, if you have a handheld calculator that's not a TI, there will be a place where you can change between radians and degrees. Now that I'm in degrees, I can do inverse sine. So it's the sine button, but it's the yellow part to it, and it's kind of fuzzy on this calculator from the image quality. But you're going to hit second sine, which pulls up that inverse sine of 0.8. And I get 53.13. So my angle is 53.13 degrees. Okay. Let's look at a couple more examples. So I have the 8 and the 18 here. Those are side lengths, and I have the angle tucked in the bottom. Right away, look across, find your hypotenuse. Attached, if this is my eyeballs, attached to the angle, I already know this side here is my hypotenuse. So the other side, the part that's also attached to it, is my adjacent, which means all the way over on the other side is the opposite. I'll color code it one more time for you. Now you identify what you are using, and I have here the opposite and I have the adjacent. So I have the O, I have the A, so I'm going to be using tangent for this call. You're going to do tangent of the angle equals, again, order matters. Opposite goes on top, adjacent goes on bottom. So tangent of theta equals 18 over 8. You can reduce that fraction to a decimal if you'd prefer. So 2.25. So tangent of theta equals 2.25. And just like before with sine, the opposite of sine was inverse sine. The inverse of tangent is inverse tangent. I'm going to do inverse tangent to both sides. The inverse tangent and tangent just reduce down to theta. And then I need to figure out what is the inverse tangent of 2.25. So on your calculator, wherever the tangent button is, I'm going to do the second tangent version of that, 2.25. And I get 66.04. 66.04 degrees. Okay. So I want to look at one more example here. This one, if you wanted to do it, you would be using cosine. But I want to look at one that has a little bit more info involved. I have here a triangle that I don't just give you 2 sides, I actually give you 3 sides. The 3, the 4, and the 5. Now originally this problem might have looked something like that, where I just gave you the 3 and the 4. And you go, oh, that's very similar to example 2 that we just did. But I might give you more info and say, hey, by the way, the hypotenuse is 5. If I didn't give you the hypotenuse, or if I did give you the hypotenuse, you would always know it, because if you wanted to know the hypotenuse, you could have done 3 squared plus 4 squared equals the hypotenuse squared, and you could have solved that, and C would have been 5, which equals your hypotenuse. So here's the part that might overwhelm someone. You have more info than you think you need. You would still want to label. You would have this is your hypotenuse, this is your adjacent, this side is your opposite, and you might go, I got the A, the O, and the H. Tangent only needs 2 of them. Sine only needs 2 of them. Cosine only needs 2 of them. What do I do? Well, you could do 3 different versions of this problem. You could say sine of theta equals opposite over hypotenuse. You could do cosine of theta equals adjacent over hypotenuse, or you could have done tangent of theta equals opposite over adjacent. All 3 of these are actually correct. I'm using the correct pairing for each guy, and all 3 of them will solve the same. Because notice, this would be sine of theta equals 0.8. This guy here would be cosine of theta needs to equal 0.6. This guy here would be tangent of theta needs to equal 1.3333 repeating. Again, they feel different. Here you would have to do inverse sine of both sides. Here you'd have to do inverse cosine of both sides. Here you'd have to do inverse tangent of both sides. Again, everything feels different. But let's take a look. I'm going to need to calculate on my calculator. I need to know what is the inverse sine of 0.8. What's the inverse cosine of 0.6? What's the inverse tangent of 1.33333? And it's referring to the same angle. So let's take a look. I'm going to clear this. I'm going to do inverse sine of 0.8. I'm going to do inverse cosine of 0.6. And I'm going to do inverse tangent of 1.333333333 repeating. And if you notice, all 3 of them are telling you your angle is 53.13 degrees. So it's your call which one of those you could use. It doesn't matter. You don't need to do all 3. Pick one of them.